So yesterday we talked about our polynomial functions. Is there something wrong with that calculator? Alright. Hand it to me if I need to fix something on it. So when you have a rational function, you're dividing polynomials. Remember, our polynomials are when you have things added and subtracted, all your exponents are whole numbers, so no fractions in your exponents, no decimals in your exponents. Remember, we know that if it's fraction, the denominator can't be 0, but otherwise we can plug in any number. So 1 over x, I told you yesterday that's a reciprocal function, but it is also a rational function because 1 is a polynomial, x is a polynomial, we're dividing 2 polynomials. From this graph, can you tell me the domain of that? And you can also tell the domain just from the function itself, because you know the bottom can't be 0, so you can plug in the 0. Your range is talking about your y. So as you go from the bottom up, it's from negative infinity until 0, and then again from 0 to infinity. So the domain and range are the same on this one. X isn't 0 and y isn't 0. Let's look at another one. So the domain of this one. So starting over here at the negative infinity, it stops when we get to negative 2. Picks up again from negative 2. And then the last piece is from 2 to infinity. Could we get that from the equation? Yeah, if we look, it's a rational function, so we just really have to look at the denominator. We know that the denominator can't be 0. What do you do with x squared minus 4? Break it down, factor a difference of squares. And so you get that your x couldn't be a negative 2 or a positive 2. This is the interval notation for that. This is when you are just writing it as sets. My general rule is if there's only one value that x can't equal, like on the previous one, I want the interval. If it's 2 or more, the interval notation becomes kind of lengthy. I would accept it either way. Yes. You could have added your 4 over and then add your square root. And if you add a square root in a problem, what else do you need? Plus and minus, so you get to the same point. What about the range of this? 0 get a parenthesis or a bracket? Bracket, it does look like it touches 0. Union, now we're going to have to kind of use a little guesswork here. So this is about the lowest y value we hit. What do you think that is? 30. Parenthesis or bracket? Bracket, because we do hit the 30. And then it's going up forever, so that would be 32. So last year we did a lot of looking at domains and ranges from graphs. At this point, range-wise, I would give you the graph to look at if I wanted to range. Domain-wise, I should be able to give you the graph or the equation. And we should be able to get there either way. What are the 2 things that we have to worry about if I give you the equation? Say that again. X. Right. Domain is dealing with the x and our possible x values. If we look at the equation, what are the 2 problems, though, that we could potentially have? This was one of them. What kind of equation was this? A fraction. If it's a fraction, we know the bottom can't be 0. What's the other thing we have to worry about? Radicals. What kind of radicals specifically? Square root, fourth root, sixth root, even radicals, we know whatever's underneath has to be positive. If it's not either one of those, what's your domain going to be? Infinity, positive infinity. Okay. Any questions on that? So then we have what are called algebraic functions. An algebraic function is anything that starts with a polynomial, but then you apply other algebra techniques to it. So you are multiplying things, you throw radicals in. Basically, when it gets ugly, those are your algebraic functions. It's not just a nice polynomial or rational or power, then it's going to be an algebraic function when you start throwing all those radicals in. We are going to skip the trig functions for today. That's going to be what we look at tomorrow. We'll do trig all day tomorrow. So I want to go ahead and just jump to the end and talk a little bit about the exponential and logarithmic. Right now, I'm just trying to touch on all these different types of functions we looked at last year and hopefully refresh them a little bit. And so we recognize these terms when we see them later on. If we're talking about an exponential function, that's different than the power function. A power function was like x squared, x cubed, x to the fifth. The variable was your base, and your power was just a number. In an exponential, that's flipped. The base is a number, and your variable is the exponent. So exponential, the variable's in the exponent. So something like 2 to the x power, 1/2 to the x power, 5 to the x power. That's exponential. When we graph those, do you remember the 3 numbers we always plugged in? -1, 0, and 1, and those would be enough to give us the graph every time on those. When I say logarithmic function, that's the inverse of the exponential, so the graph is similar but kind of flipped on its side. Logarithmic function, you're going to be able to recognize it because it's going to have the word log in it. We will see those coming up a lot in here. In calculus, most of the time we will see ln of x in this class. Ln, remember, is just log with base of e. So that'll be the form that we most often look at in here. So, this example, I just want to see if we can classify each of these functions. So if it's 5 to the x power, variables in the exponent, that's exponential. What is x to the fifth? There's really 2 different things you could call this. This is a power function. What's the other thing you could call it? Look back through your sheet, things we talked about. We did linear, polynomials, powers, rational, algebraic. Well, it's to a fifth power though. So this is a polynomial, isn't it? A power function is just a polynomial. Power function is probably the best term for it. It's the most specific term, but if you called it a polynomial, I couldn't count it wrong because that's correct. It is a polynomial. C. It's got a fraction, which makes me think rational. But remember, if it's rational, you're dividing 2 polynomials. Is this bottom one a polynomial? So when it's uglier than that, what do we call them? Algebraic. And last one. That is a polynomial. What's the degree of that? 4. I want to give you guys time to work on homework. I might start some of the trig stuff towards the end. We'll just see. You guys don't want to be bored. So yesterday I gave you 4 problems, so that means I'm only adding 3 of these today. So we need to add in number 1. Let's see, okay, 19 and 27. So you can do them out of order on your paper. One thing I wanted to mention on problem 21, it asks you to make the scatter plot and do the least squares regression. That's when you just use your calculator and do that linear regression and get the equation. So I am giving you guys a lot of class time right now to work on this, and hopefully you can get that done.